Hi there, math students. One more day on slope-intercept form. Again, remember y equals mx plus b. That's what we're using for slope-intercept form. The m is the slope, but that's how we move. The b is the y-intercept. That's where we begin on the y-axis. Today, we are going to add a little bit to it. We had 2 days of just graph with slope-intercept form. Sometimes, though, I may give you an equation, and it might not be exactly in slope-intercept form. However, we've already learned this topic also. We know how to rearrange equations. We're going to be working today to get equations into slope-intercept form so that we can work with them from there. So these first 3 equations, I'm not even asking you to graph these. I just want to find the m and the b. I want to find the slope and the y-intercept. The first one is pretty easy. The only trick here is that I need to know that there's really a 1 there, and I might want to do that. So my m, it's actually -1, or -1/1 if I was graphing, and my y-intercept is -2. The problem with the second one is that it doesn't look like this. Slope-intercept form has the y all by itself. So I would ask, how do I get rid of subtracting the 2 that's with the y? And you guys know that. We're going to add 2. And that 2 does not match the 5x. Those are not like terms. So this is just going to be y equals 5x plus 2. So the m is 5, and my y-intercept, the b, is 2. On the third problem, the y is by itself. That's what I wanted. It's great, but it's not quite in slope-intercept form either. One thing that I do see some people do is that they just flip-flop these two things, and they think that the slope is 2/5 and the y-intercept is -4 because there's a subtraction. But it's not really that. I would want to do a cube change. So when I write this in the right form, I would have -2/5 x. That's really the thing that's negative, plus 4. So my m is -2/5. My b is really 4. Some more problems like this, just practicing rearranging. So in the first example, remember, I want the y to be by itself. This is the guy I'm worried about right there. So I would start by getting rid of this, adding 2x, and I would do that by subtracting 2x. And when you write this, when we did our literal equations, rearranging equations unit, I said, hey, it's standard form. We always want the x thing first. This is primarily y. When I write this, I don't want -4 minus 2x. It's not that that's wrong. It's just that it's not in slope-intercept form. If I want slope-intercept form, it should be -2x minus 4. So my slope is -2, or -2/1, and my y-intercept is -4. The third problem, or the second problem on this slide, I'm sorry, I am a little bit concerned about this one because, again, I know that some people see, I'm going to make a mistake right now, some people see subtraction, so they say, oh, to get rid of subtraction, I'm going to add. But now I have x plus x, which is really 2x, and that's not what I want. So I want to do a cube change. You can sneak a 1 in there. I could even put a 1 in front of this x. The y is what I want by itself. So I want to get rid of adding 1x. I would subtract 1x. Now that would actually get rid of it. So I have -1y equals -1x plus 3. But I don't want -1y. I just want +1y. So I have to divide. And if you remember back when we did this, we would have to divide. Everybody gets divided by -1. So I get that y equals +1x minus 3, or plus a -3. So my slope is 1. My y-intercept is -3. For the last example in this slide, I'm hoping that you can see you're going to have to be doing some division on this one. Remember, I want the y by itself. Right there's my y. But it's attached to the 2, so the 2 is going to be the last thing to go. I want to get rid of the 4. I would subtract 4x. I should say I want to get rid of the 4x, not just the 4. So I would have 2y equals, and again, remember standard form or slope-intercept form, I want the x thing first, so it's a negative 4x plus 10. And then I want to get rid of the 2. I would divide, divide, divide. Y equals negative 2x plus 5. So my m, my slope, is negative 2, and my y-intercept is positive 5. Those practice problems, just getting the m and the b, that's really leading into this. If I give you these equations, we should still be able to get them into slope-intercept form and then also be able to graph them. So in this first example, and by the way, I haven't been doing this, but if this helps you, absolutely go ahead and use that vertical line. I want to get the y by itself. So the 6 is going to be the last thing that goes. I'm going to subtract 3x from both sides. So I have 6y equals, we want the x thing first, so negative 3x minus 12, or plus a negative 12. And then I have to divide by 6. I can totally see some people, remember divide, 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 looking at that and saying that my m, the number in front of the x, is going to be a negative 2. But it's not, because the small numbers on top, negative 3 over 6 is really just a negative 1/2 x plus negative 12 divided by 6 is negative 2. So my slope is a negative 1/2, and my y-intercept is a negative 2. Now that I've got that, I can actually look at this graph. So my y-intercept is negative 2, got it? My slope is a negative 1/2, which means I'm going to go down 2, or I'm sorry, down 1 and over 2. Or I can go up and left. Remember, left is negative, so that still gives me a negative slope. For the second problem here, I need to get the y by itself. So let's do a keep, change, change. Let's subtract the 3x. So negative 2y equals negative 3x plus 8. And then everything gets divided by the negative 2. Divide, divide, divide. Some people see this and they start to freak out a little bit, even though fractions are our friends. Don't forget, we want slope to be a fraction. So negative 3 over negative 2, that's 2 negatives, that's going to be a positive. Just keep that as 3 over 2. Remember, we do not change that into 1.5 or 1.5. We want improper fractions if it's going to be a fraction. And versus a mixed number, I should say. The 8 divided by negative 2 is going to be negative 4. So my slope is 3 over 2, and my y-intercept is negative 4. So on my graph, negative 4, 1, 2, 3, 4 is down here. A positive 3 over 2 slope is going to go up 1, 2, 3 over 2. And I would do that a couple of times. So up 1, 2, 3 over 2. And right there's our line. Okay, we did look at problems like this when we were solving for a particular variable, and sometimes we said it was just faster to move the y to the other side of the equal sign. So if you wanted to on this problem, you could move the 2x and you could move the 9, or I'm going to do this one that other way. It is okay to move the y to the other side if it's getting the y by itself. So I would have to subtract 3y. I know that's not how slope-intercept usually looks. We like the y to be on the left, but we can flip that later. So I've got 2x minus 9, or plus a negative 9, equals negative 3y. So I would have to divide by negative 3. Divide, divide, divide. When I write this, I'm going to flip it back so that the y is first now. I would get 2 over negative 3 is just a negative 2/3 x. And negative 9 divided by negative 3 is positive 3. So my m is negative 2/3, and my b is 3. So that graph starts at 1, 2, 3. My slope is negative 2/3, so that's down 2 sideways 3. That's all I can fit that way. I suppose it's going to kind of run into my work here, but I could get a point right there also. And there's my line. This one looks a little different because there's not even an x in here. But let's just first start with getting the y by itself. I would add 4 to get the y alone. So this is going to be y equals 4. If I don't have an x, it's because it was really 0x. That's not ox, it's 0x. So that means that my slope is 0 and my y-intercept is 4. So the y-intercept is 4. That one's easy. 1, 2, 3, 4 right here. 0 slope, think about Mr. Slope guy. That's a horizontal line, or 0 over 1, I could say. So I'm going to go up and down 0, I'll go sideways 1. Well, that's my horizontal line right there. So if there isn't an x, it's not going to touch the x-axis. Here's our last problem. This is from today's worksheet. I need to get that equation into slope-intercept form. And in fact, I would probably use that method that I just showed you about moving the y, because there's nothing on that other side where it's just equal to 0. So I would add 2y. And again, as usual, I picked the hardest problem to do as this example with you. So I think this is going to be the toughest one on the whole worksheet. But I don't want 2y. I just want y. So we have to divide, divide, divide. So 2 over 2x, that's just 1x. 5 over 2, now this isn't a slope. I don't need a fraction here. That's the y-intercept. 5 divided by 2 is 2.5. This is really the reason that I picked this problem. The y-intercept isn't a whole number, which is not typical for us, right? If I would rewrite this now so it looks like slope-intercept form, I'm going to get y equals 1x plus 2.5. My m is 1, or 1 over 1. My y-intercept is 2.5. So we got to think about where that 2.5 is. 2.5 is right here. If my slope is 1, that means I'm going to go up 1 full square from where I am, which means I'm still in between, and over 1 full square. So up 1 square, over 1 square, right there. Up 1 square, over 1 square. That's what my slope is going to look like, or down 1 square and over 1 square. Okay, so when I draw this line, it's going to hit letter E on the outside. Read the directions on the worksheet for how to answer the riddle, but the answer for number 8 is letter E. So today's worksheet, there is some work to show to get slope-intercept form. Feel free to use the back side of the worksheet or a notebook paper, or if you can write small next to each graph is fine, but it's the why does a poor man drink coffee worksheet. When you finish that, make sure that you do your learning check in Schoology. Let me know if you have any questions.